Yes. And today is the 15th. Yes. Before you say anything, there was a problem on the quiz on Tuesday. Something like this. I don't remember the top. Correct me if I forgot something. And my students wrote 2x minus 3 not equal 0. We never state a restriction on the numerator. The numerator can be 0 unless it has a square root, or it has a function that needs, whose domain is not all real numbers. But we never state a domain or a restriction on the numerator unless specific cases happen. So the only thing that I was expecting my students to write was this, which means x equals greater than 1/2 or 1/2 to infinity. Just one blink. Just want to make sure that this is clear. You cannot just try to fit into a category that you saw. You have to think, right? Please. We do not state restrictions on the numerator ever unless the numerator is a function that has restrictions. Okay. Samantha, I'm ready.
Well, since I wasn't here at all last class, I think it's probably better if I just watch the videos.
Oh, okay, well, if you find something, let me know. I posted the lecture notes as well. I'm so sorry. I always scan them right away so I don't forget, but I forgot to upload them. But the videos are there.
Okay.
Anyone else has any questions for me? Anything? Any questions? Okay, well, in that case, I will continue with 2.8. 2.8 has 3 different things that we have to look at. Number 1 is the distance formula. The second one is the midpoint coordinates. So this is number 1, this is number 2, and number 3, the circle. Or if you want to write the equation of the circle, that's fine too. So let's start with the distance formula. Let's drop 2 points. Let's say this point, let's plot 2 points on the coordinate system, point A and point B, and they are connected by the line segment AB. And we want to determine the distance between the 2 points, or the length of the line segment AB. Okay, so I'm going to denote the coordinates of A by x for the first point and y for the first point. I'm going to denote the coordinates for point B, of course, as x for the second point and y for the second point. I'm going to form a right triangle. And I'm going to try to use the Pythagorean theorem in this triangle and determine D. But the question is, I will be able to do that, but I need this length. I need to identify how long this is, and I need to identify how long the other leg is. And then I will write that the distance squared equals leg 1, this one, let's say leg 1 squared, plus the other one is leg 2 squared. But I need to determine the length. So can anyone give us this distance? From what you see here, how much will this be, this length? And then I'm going to ask you about this. Let's say if this is 1 and this is 5, what will be the length? If this is 1 and this is 5, how long is this?
4.
4, which means x2 minus x1. In general, x2 minus x1, 5 minus 1, 4. Good, we're getting somewhere. What about this leg? What is the length of that one?
y2 minus y1.
Right, exactly. y2 minus y1 will give us this. I'm going to put it here. y2 minus y1. So I got the Pythagorean theorem that d squared equals x2 minus x1 squared plus y2 minus y1 squared. Now I have to be careful because I want to take the square root and find the distance. So when I take the square root from the left-hand side and from the right-hand side, do not attempt to simplify this. It's not possible. So when we take the square root from the previous experience that we had in the last month and a half, we know that we have to put plus or minus and the square root, right? In this case, I will erase the minus. Why would I erase the minus in this situation and I will not let it in? Why?
The distance can't be negative.
Thank you very much. Because in this particular situation, although algebraically plus or minus is the correct answer, I can't have a negative distance. Great job. Do not attempt to simplify this. The sum of squares with a square on top of it, the square root on top of it, cannot be simplified. I'm gonna move you further away from me a little bit so I have more room here. Sorry. Okay. Give me two ordered pairs. Any two ordered pairs, and let's find the distance.
5, 7.
Some negatives, or one negative at least, or something in there.
Okay, and the negative 2, 3.
Excellent. I will denote them. x1, y1, x2, y2. I will write the formula. x2 minus x1, everything squared, plus y2 minus y1, everything squared. I put those numbers underneath so I don't make a mistake, and I don't have to use nested parentheses either. x2, negative 2. x1, 5. y2, 3. y1, 7. So now the distance is the square root. Negative 2 minus 5, negative 2 minus 5 is negative 7 squared plus 3 minus 4 is negative 4 squared. If at any point in time you get something like this, a negative number when you square, no matter what you square and you add, this number has to be positive. If you get something like this, you know this is terribly wrong. Something is not right. 7 squared is 28. 4 squared is 16. I have to add them. So 28 plus 16 is 46, is it? 44? I have to simplify it. In some problems I will have to approximate it. In others I will have to simplify it. But this is the same thing with 4 multiplied by 11, or 2 the square root of 11. This is the exact. If I want or am asked to approximate it, fine. I will write D is approximately, and I'll put it in the calculator. Where's my calculator? Here. And square root of 44. 6.6332. This is how we determine the distance between 2 points.
Why
Yeah.
is it 28?
I'm sorry?
Why is it 28 instead of 49?
I'm sorry. I don't know, in my mind I multiplied 7 times 4. Keep an eye on me. I wasn't trying to see whether you were asleep. No. I was asleep, apparently. I'm sorry. So it's 65. No excuse. Of course it's 49. Sorry. I'm sorry.
You're forgiven.
I shouldn't be, but thank you. And no, as I said, no, I wasn't checking anything. I wasn't trying to be smart. See if anyone catches. No, I wasn't. Apparently, I'm losing my mind. So now moving forward, I have to check everything 3 times. Sorry. Okay. I had to erase that so not get anyone confused. So then these approximately the square root 8.06. Thank you for paying attention. You should not trust me the rest of the day. I wouldn't. Okay, very good. Thank you so much. My apologies. So this is indeed 49, and this is 65. Good. Sorry. Coming back to our graph, there is something called midpoint right here in the middle that divides or splits the line segment into 2 equal parts. So I'm going to graph it again here. So this is our A, this is our B, and right in the middle we have M. In the same way, we can show that the coordinates of the midpoint are the average of the x values. What does that mean? Add them up and divide by 2. Average of x1 and x2. Add them up, divide by 2. The same thing for y. Add them up, divide by 2. So coming back to our example, I'm going to determine the midpoint. And 5 minus 2 is 3, so it's 3 halves. And 7 plus 3 is 10 divided by 2 is 5. So these are the coordinates of the midpoint. And this was our second item on the agenda for finishing up chapter 2. One more, and we can start chapter 3. Okay. Let's take a look at this graph. I'm going to say, please consider this an approximate circle. Of course it's not. It's as perfect as I could have done it. And the coordinates of the center are denoted by h and k. H is the x coordinate of this point and k is the y coordinate of this point. Somewhere along the line, let's say we have point A of coordinates x comma y. That can be anywhere. These 2 points are connected by the radius. So r is the radius. The circle, what does the circle represent? It's a set of points that are always found at the same distance from the center, r. So it's a set of ordered pairs, and they're all at an equal distance from the center. And that equal distance is r, denoted by r, the radius. Okay, coming back to what we did a minute ago with the distance formula, I'm going to use the distance formula on these 2 points. So I'm going to write them again. So A coordinates x comma y, and C coordinates x comma k. And I'm going to write the distance as being the square root of x2 minus x1, x minus h, everything squared, plus y2 minus y1, everything squared. And this distance is the same with the radius, right? The distance between A and C, exactly the same with the radius. So there is no need to write the distance. I will replace it by r. I am going to square both sides. This is done. This is good. It's good enough. But we prefer to present the equation of the circle after we square it. So then, when I square the left-hand side, I get x minus h, everything squared, plus y minus k, everything squared. I must square the right-hand side, so I get r squared. What does this represent? The equation of a circle with center h comma k and radius r. In this section, we have three types of problems. Here's the first type. The first two I can make up on the spot, but the third one we have to pick from the book. I can make it up on the spot. Okay, so the first type is given the center, give me a center, and give me a radius. Find the equation of the circle. So give me a radius, not too big because I'd like to graph the circle also. Okay, let me make it a little bit smaller because then I have, you know what, let's use 7. Doesn't matter, I can use a different unit. Good, and the center. Can anyone give us a point that is the center? Not too far out, like negative 100 to comma a million, because I want to graph it too. Negative 2 comma 3. All I have to do is write the equation of the circle, the general, which is x minus h, everything squared, plus y minus k, everything squared, equals the radius squared. Replace h by negative 2, replace k by 3, replace r by 7. Perform the operations carefully. X minus negative 2. This is x plus 2 squared plus y minus 3, fine, squared, equals 49, not 28. Okay, good. So this is the equation that we were asked to determine. We got it. Now I'm going to throw in also graph the circle. Okay, the center, we have to plot the center first. And the center is negative 2 comma 3, 1, 2, 1, 2, 3, right here. At this point, I have to create 4 points. I can create 10 points, but I only need 4. 4 points that are exactly 7 units away from the center. 4 points. South, west, north, east. South, I have 3 here. 1, 2, 3, 4. So this is 1. South of the center. 1, 2, 3, 4, 5, 6, 7. 1 north of the center. 2, 3, 4, 5, 6, 7. East. And 1, 2, 3, 4, 5, 6, 7. Of course, my graph is not going to be perfect. Far from it. So this is negative 2 comma 3. And this all points on this circle must verify the equation x plus 2 squared, and they will. Plus y minus 3 squared equals 49. Second type of problem, that was straightforward, easy. Second type of problem, let's say we are given, any questions please? Any questions? So given this equation, x plus 7 squared plus y minus 3 squared equals 25, identify the center and the radius. Can anyone give us the center and the radius?